We're doing it.
Hello,
Hey, everyone.
everybody. Welcome to Codecademy.
Yeah.
My name's Tim,
And I'm Kenny.
and we're going to be walking you through some phaser today.
Yeah.
Just want to know how y'all are doing.
Yeah.
Let us know in the chat. Chime in, please.
Please. Our course is based on a lot of like old arcade classics. So if you guys have any favorite classical games that you enjoy playing, put it in the chat. Maybe we could have a discussion on how to make it later if we have enough time. We'd love to hear from you. And I think we're just going to wait a couple of minutes for some stragglers to chime in, join us. Hi, Mama Wolf from Portland. It's great to have you. Yeah.
If you're in the YouTube, if you're watching the YouTube, you can go down to the description and click into the Codecademy learning environment, which is where you'll be able to follow along and code along with us to build this game that we're making.
That's what you're seeing on screen right now. If you want to join in on the live stream or you're already on the Codecademy site, you can click on the YouTube embedded link on the left-hand panel as well, and that'll bring you to here.
Yeah, just make sure that you're not playing the audio or playing the video in both separate YouTube tab and on the learning environment, because then you'll hear a weird echo.
I'd say it's more of a feature, right? Like it's one of those things.
Mm-hmm.
Extra
It's definitely
benefits.
a feature. You'll hear twice as much phaser knowledge if you have it open in two places. So where are you all? Well, Portland. That's pretty cool. It's like 40 degrees Fahrenheit here today. So it was just about to start warming up over the weekend, and now it's going to be cold again. That's March for you, I guess, here in New York City, where we are. Iowa, Chicago. Wow.
We got a lot of Americans here.
Dragon's Lair. I'm not familiar with that game. Have you?
Not Alex. Alex is moderating for us today. He's off in the corner.
Alex Kuntz, the unsung hero, who we love to sing the praises of.
Yeah, anytime. Plus one on that.
Yeah.
South America, wow, international people. This is awesome.
Yeah, Miami's not too cold. I'll be there later this
Okay.
week, so I'm excited.
Ooh.
Gonna head down to Miami.
Yeah, good. I mean, you should get some of that warm weather before.
The birthplace of indigestion.
Oh, what?
Is that what Albuquerque is really known for?
Maybe that's the game that Ryan really enjoys playing.
Birthplace of indigestion. We'll go over tips on how to make birthplace of indigestion later.
Oh god, I should hope not. I don't think you really need tips on that.
Yeah.
Another one from Toronto, a Brazilian living in London. Hi everyone.
Yeah, what are your favorite arcade games? Let us know. We'll be building Frogger, which is a classic. There's a couple of other real Uruguay, Czech Republic. Wow, very cool.
I think, yeah, and Tim was mentioning in our other courses, our two other courses, we build out like other games that have been inspired from arcade classics as well. One being like Space Invaders, so we did our own take of Bug Invader on that.
Mm-hmm. Yeah, and I did one based on Color a Dinosaur, which is really obscure, not totally well-known game, but the basic idea of having a coloring book, I guess, kind of goes back to Mario Paint, maybe.
It's really fun though.
Yeah, I think it's a really enjoyable experience.
There's also a Code Your Own Adventure, or Choose Your Own Adventure game. It's interactive, and you get to see what options you go through as you click through the text input from players, from NPCs.
Yeah, it's a fun one. I see Matt Mullen in the channel. That's my brother, so.
Taking your advice.
Yeah, definitely an interesting audio effect.
Cool.
I guess maybe we should start moving into some code here today.
Yeah.
Hi from Syria. Wow. And please, you're in the chat now. If there's any points you feel like you want to ask questions, ask them.
Yeah.
Oh, how long will this take? This is slated to be about an hour.
Yeah.
Yeah, that's our plan.
If you can't make it through the entirety of this stream, it's going to be uploaded as soon as we finish. So we would love to still thank you guys for joining. And for those who are in the chat right now, take advantage of it, like Tim was saying. I'll be devoutly looking onward to what's going on in the chat. And Tim's going to be demonstrating a lot of what's going on in the live stream. Okay.
Cool. I'm going to talk a little bit about what's already here. And so a couple of things are in this workspace. Let me gesture at the text that's right here. So here's you should be loaded into your game.js file, and then there's an index.html. And you don't need to know HTML to create phaser games. We use a very minimal amount. It's a very small HTML file here that's just kind of describing what the title is of the page itself, and importing the phaser library, and then importing the game.js file that we have over here.
Right.
And so this is a basic skeleton for a phaser game. You've got a config, you've got a new game, and you have a couple of scene functions, and I'm going to talk a little bit more about what that is. But first we're going to cover this config here, where we just describe the properties of the phaser game. So how wide it is, how tall it is, what the background color is by default, and the scene information that's in there.
That's awesome. Yeah, and in our course, we might refer to it as like meta information. You might have, if you're reading or going through our course, that's exactly the same thing that Tim was mentioning before. So
yeah, and I highly recommend, I mean, after this, before this, after this probably now, going over the course, we certainly cover all of this probably in a little bit more detail. But since we're going to try to, shoot through this and make a game, we might breeze over some details that you might be more interested in. So ask questions in the chat and run through the course itself. It should be helpful. So here in preload, we've loaded in a couple of images, some sprites that we're going to be using for the game. There's 3 bugs that we're going to be using as our cars in the Frogger worlds, and then there's our Codecademy mascot character who's going to be the frog from the Frogger. And so the first thing that we're going to do is take this loaded in sprite and bring Cody to life on the screen. So we're going to, game state. Yeah, we manage states in phaser games in this kind of global way, in this game state object. It just helps us pass information in between the various functions that a scene has.
right.
You want to reiterate
Yeah.
that a little bit?
I think the major point is, like, you notice that we have a lot of different functions here. We have preload, create, and update. If we want to use the same variables throughout, we'll need that global scope to access it in create and in update. And so game state is just like holding on to properties that we can then use in those different functions. And I think that'll be more clear once we start implementing it, especially even with our first step, because we're going to make Cody, and then we're going to make in create, and then we're going to make him move in update.
Yeah. So we're going to start with create, and we're going to add our first line of code. So are you ready for this? We're going to create game state.cody. That's going to be the place that we store this Cody game object, right? And the game object itself is going to be a sprite. So this .add.sprite is the name of the function that adds a game object that corresponds to a sprite to a phaser game. So this .add.sprite has 3 arguments mainly. The first one is the x coordinate that we're going to be displaying Cody. The second one is the y coordinate that we're going to be displaying Cody. And the third is the key, which is the name that we gave the image when we loaded it in preload.
Yeah. We should talk a little bit about the grid too, like x and y coordinates for a second.
Absolutely.
So for the coordinate system in Phaser itself, we actually start in the top left-hand corner, and that'll be 0, 0, or the origin. And as we move down, we're gonna let's start with the x. As we move to the right, we're gonna increase the x coordinate, and as we go down, we're gonna increase the y coordinate.
So a lot of you may be remembering algebra, math, might be thinking that it's a little inverted because the y coordinate will go up in that case, usually. But here in Game Worlds, it just makes more sense for us to be going up as the y goes down, sort of. Yeah. You get used to it. It's not super, it's a little jarring at first because you have to flip some of your negative signs, but eventually it's pretty standard also.
Yeah.
It's common in JavaScript. In the canvas is the name of this, like
the canvas element, the canvas API. If you're used to using JavaScript to draw stuff on canvas or WebGL, might hear that term as well. You'll probably be used to this coordinate system, but even now it takes me a while to think about how to increase X or Y. Don't worry, it's a learning curve.
So what we want for Cody, the place where we want Cody to appear is right here in the center of the bottom. And we're going to make Cody jump up or like move upwards towards the top of the screen, where if Cody successfully gets to the top, then we're going to have like won the game. So we want, what I recommend doing is using these width and height properties that we've given to the game in order to say we want it in the center and at the bottom. So in the center for the game would be config.width divided by 2. So that means that it should be right in the middle. That corresponds to this x value here. And then if we give it config.height, and then we subtract 25. The Cody sprite is a 50 by 50 sprite, so subtracting 25 is half the height of Cody. Right. And the sprite, these x and y coordinates are the middle of the sprite, are going to indicate the middle of the sprite. And I'm just going to go ahead and type in this last bit here so that we see Cody and kind of get to talk a little bit more about what these values are. So you can see Cody is appearing halfway across, that's config.width divided by 2, and Cody is appearing right at the bottom, and that's the height minus half the height of Cody, so that the centering works all together.
If you're coding along with us, I would encourage you guys to just play around with these arguments just to see where it pops up. That really helped me solidify my understanding of these XY coordinates. Tim, can I do one thing?
Yeah, absolutely.
Just like stretching this out.
Oh, right. Yeah.
So makes it a little bit bigger for you guys. Hopefully it makes it easier to follow along as well.
Yeah.
Okay.
Cool. I'm going to move this over a little bit too.
Sweet.
So yeah, to kind of just like follow along with what Kenny was saying, if we change this to 20, for instance, and then run it, you'll see that Cody is moving a little bit further down. If we just give it a bare config.height, Cody's barely over the bottom line there. So these numbers are absolutely numbers that you end up playing around with a little bit to make sure that everything kind of sits on the screen the way that you expect it to. Don't expect that this like config.height minus 25 is something that I came up with immediately as I was writing this code. Like some of this has been we've obviously tested through to make sure that we could make Frogger beforehand. So if it's frustrating to like see this kind of magic number, it's like kind of part of the experience of coding a game and like an interface.
Yeah, and Rick Marshall asked a great question. Oh, sorry, not Rick.
OBME Thomas.
OBME Thomas, thank you. About what a sprite is, and in this case it's representing our player Cody, but we can also use it. We're gonna use it later to represent enemies and things that are in our games.
Yeah, I'm going to start moving on to the cursors because what we really want to do is start moving Cody in the game that we've created here. So what we're going to do is we're going to create a GameState.cursors property for our GameState. And we're going to add it to our GameState so that we can access it in the update function. The update function, do you want to talk a little bit about what the update function does?
Yeah. So for update, and we'll get to this later, but it's running, 60 frames per second? Is that? Or
something like that, 33, I don't know.
It's trying to get
every 16 milliseconds.
Yeah. I don't remember the exact numbers. You can definitely look it up later, or if I have a chance, I can look it up as well. But the flow of our game works like we load in our assets through preload, and then in create, we're running that function after preload, and we're adding that to our games. And then later on in update, that's the function that keeps on running and checking and making sure that our game is actually flowing. So in update, we would be like doing a check to see if any cursor or any like keys are being pressed, cursor also being like a mouse click or any sort of input. And that way we can then interact with our game and change how our game is being played.
Yeah, perfect. So here we are in create, and we're going to create our cursors, and then in our update, we're going to use the input that we've given to our cursors in order to move Cody on the screen here.
Yep.
So the first thing that we're going to do is set game state.cursors equal to, not that, this dot input dot keyboard dot create cursor keys. And this is a bit of a magic way of adding in the arrow cursors, up, down, left, right, and also gives you controls for shift and space. So just to kind of like go over a little bit more about what's going on here, this is the scene, the phaser scene in which everything is taking place. And the scene has a number of convenience functions and factory methods that allow you to build in phaser primitives, I guess, quickly. The idea is to get you going from 0 to a full-blown game as like quickly and with as little boilerplate as possible while still being very extendable. So this .input.keyboard.create cursor keys might seem like something you have to kind of like memorize at first, but it's something that you're going to kind of start to intuit a little bit more as you build more phaser games. And that is 100% our plan for you, is for you to build a bunch of phaser games so that it's really second nature.
That and this stuff is not meant to be memorized at all. We've provided in the left-hand corner, if you expand that, a bunch of links that you can go to, documentation. Phaser also has a bunch of lab examples on how to bring this into your own game. And there's also Rex Rainbow's awesome documentation as well. So don't feel obligated to memorize this. This itself is a very confusing JavaScript thing. And so if you're not comfortable with that, maybe it's also good to take a step back and brush up on some JavaScript.
Absolutely. I think our next step here is to start looking at these cursors and using them.
Sounds good to me.
Excellent.
Okay.
So we're going to go into our update function here, and we're going to check, let's say, if GameState.cursors dot left, okay, dot is down, right?
Yeah.
And what that is going to see is whether or not we're pressing down the left arrow key on the keyboard.
Right.
And what we want that to do is to move, oh, I used player in that. I'm going to switch this over to player, actually.
Okay.
Just to be consistent a little bit with the notes in case I don't mix myself up here. I know I called it Cody there. Player works just as well. So I'm going to fix that .y, and what I want to do, since we're moving left, that means the x value needs to go down.
So let's change that to x.
Let's change that to x first of all, and then minus equals 5, let's say. And that's another kind of magical number. We'll see as we save here and we move Cody a little bit to the left. I think it feels kind of nice. I think if we set that to 1 instead, Cody moves a little too slow. It's not as fun, and that's kind of like one of those real personal choice things that it comes down to, is how fun does it feel to move Cody. As a game developer, that's kind of up to you. So I'm going to save this, and we're going to start building out the rest of these checks. And so what we want to do is create an else statement.
Also, nice.
Yeah, I'm not going to write elif like I usually write.
It's a Python thing?
That is a Python thing.
Gotcha.
I'm going to do that wrong, though.
Well, we need, parentheses. Awesome.
Yep.
Alright, it's my last time now. Yes.
Cool.
Do you want to respond to that?
Player
Thank you.
x plus equals 5. And so now we've checked if we're moving left or if we're moving right. So that's what this GameState.cursors, that refers to the create cursor keys thing object that we built up here. And then left is one of the properties of that. And then you can check is down on the left key, or you can check is down on the right key. And we're going to be using both of those. So here we are, moving left, moving right. Excellent. We're already well on our way to building out Frogger. That's basically our core axis of motion. Actually, we'll have to add the y value changes too. And we're going to be a little bit different with how we move Cody in the y axis.
Yeah.
Because in the Frogger game, you jump a whole street, kind of. you move a little bit to the left and to the right, but you jump a whole lane is the phrase that I've been using for this. Like, you can think of the game as broken up into several rows, and you jump a whole row up instead of just a little bit. So what we want to do there is I'm going to talk about just down a little bit, I guess.
Sure. So for just down, unlike what we've been using before for like game state cursors left is down, we're just checking for we can continuously press left or right in the first conditional, and Cody will continue to move left. So we don't have to keep like lifting our finger up and tapping down again. We can just hold it down and it'll keep moving to the left or to the right, right? Whereas in this method, phaser input keyboard just down, it's checking for the game state cursor up in this first case, and every single tap is going to then trigger something. You cannot just keep holding the up key down and expecting Cody to move. You'll have to continuously tap.
Yeah. So you're not going to just kind of like sprint upwards. You're going to go up in very discrete motions. So here's a question for you, the viewer. We are checking our up key events. Which direction do we want to move Cody in? Or what should we do to the Y value? We're going to add or subtract 50. 50 is the height of Cody, so that Cody moves up a full lane. But are we going to add or are we going to subtract the 50 in order to move Cody up? And while you ponder that and respond in the chat, I'm going to add the second step, which is bringing Cody back down.
Okay. I already see some people chiming in. Few subtracts. Are they right?
I think they might be. It's very possible.
Subtract since you're moving towards the 0. Oh, Sean. Module.
Modulo. Yeah, we're not going to use modulo.
I think we have an outlier. Wasn't even one of our choices,
Yeah.
but
Yeah, it looks like everyone's kind of got it. So minus equals 50. Exactly. That's correct. That is 100% what we want to do because we're moving closer to 0 from config.height. Right? And that's like this value that we've assigned Cody to up here, config.height minus 25. We can work that out. It's 600 minus 25, which is 575. I have a math degree.
I got lost there, but okay.
Yeah, so we're going to subtract 50, and we're going to bring, that's going to bring Cody up. And for the opposite direction, I'm going to add 50 to bring Cody back down. So we're going to save this.
So I noticed you add that as a separate if statement. Could we join that as like an else if? Like
Yeah,
it's either
you don't want to move back both up and down. So I didn't chain the else if from this first block here because you want to be able to move left or right as you move up or down in order to better evade the cars, I want to call them. We're going to be using bugs as the example here.
Enemies. We could just
enemies,
call them enemies.
yeah. The things that make Cody go splat. So here I'm just going to save this, and we're going to see that Cody can move up and down. That's really good. Unfortunately, should we start talking about bounds?
Yeah, we can talk about bounds, but also for anyone who is coding along and is a little lost, we've also included in the folder on the top left-hand corner a series of steps. Yeah. The first step and cursors, and you can copy and paste that, and we'll stop along each point as well. And if you get lost along the way, feel free to copy and paste that in, and that way you can just get started again with what you need to for the next steps.
Yeah, it's an excellent way if you are coming back to this and you want to see what the final game looks like. You can come down to this last step and you can copy and paste that, and then you can kind of erase that and add in the code as you build it yourself. Cool. So back to game.js, and we are going to continue building on this. So a bit of an issue here arises as we can just walk Cody completely off the screen. And that's not going to be good. We don't really want that. You can move down, you can move up onto the other side of the screen. We want Cody to stay in the game. That's where Cody belongs. So we're going to add bounds to these if statements to make sure that Cody isn't going to step out of bounds after we move Cody further out. And so when we check for the left is down, we also want to check that GameState.player.x is greater than 25. That means that Cody can't continue moving to the left after Cody is always as far to the left, or already as far to the left. And let me just save that and show you what I mean by that. When I move all the way to the left here, that's it. And that's where Codecademy, or no, Cody. Cody's x coordinate here is 25 because that's the center of this sprite. So a little, I guess, a little maybe confusing about how phaser assigns the centers of your x and y coordinates. There's ways to change it if that's something that you don't like using the set origin method. We go into that way more in depth in the courses. So we're just going to kind of keep on moving here and add some more ways to keep Cody within this box. And so the next way that we're going to do is GameState.player.x is less than, what I'm going to do here is config.width minus 25. So that's, that's a whole lot to say, a whole lot to say, make sure that Cody doesn't move all the way to the right off the screen in that direction.
Save it again. Awesome.
Saving it, and you can see that Cody does not go out of bounds in that direction either. And we're going to add that also to our up and down checks as well. So we're going to do GameState.player, not Cody, .y, and we want to make sure that that's more than 25 so that Cody doesn't move further up after the top. And we're going to also just keep on going. I'm going to trust that you trust me now to know that that's going to work. And we want to make sure that the y value is not is less than. Sorry.
Yeah, Alex, that's a great suggestion.
Config.height minus 25. So we're using a lot of this. Oh yeah, the fun extension. That is a fun one. We're not going to get into that. You should think about it. So you can see now, and if you followed along with the code, that we can't get Cody out of the box. And that is exactly what we want.
He's trapped in there.
He is trapped. There's one trapped Codecademy mascot.
Sweet.
Excellent.
Like Snake, yeah.
Yes, yeah, like Snake. On the Nokia, yeah. That's the
really old
deal. The old brick phone. I miss them.
Indestructible.
Yeah, a pocket-sized phone for a past generation.
At this point, if you guys are coding along, we've gotten up to step 2 as well, where it's creating boundaries, I think the name is called. If you have any questions, as always, please ask in the chat. But we're now going to move on to the next step, I guess. So the next logical thing, I think, in this case, is maybe making the roads that we need for Brody to cross.
We need to kind of set the scene. We need to give this a little bit more context. Cody just moving around in a green square is fun enough, I guess, but a game doesn't just have to be playable. There's got to be kind of win and lose conditions, and it's got to put you in an environment, really, and give you circumstances to deal with and think about. So the first way that we're going to start to indicate that is by adding in these roads. So we're going to start with, we're going to make 2 roads. We're going to name them Road 1 and Road 2. There's an extendable way if you want to make, I guess, an unlimited number of roads. You can make a roads, GameState.roads, but since we're going to kind of make this small and within this little box here, let's start with with just 2 roads, and we'll talk a little bit maybe at the end if we have time about how to make an infinite Frogger game, I guess.
Infinite Frogger game.
Yeah,
wow.
You can never win. That's what we love, right?
The best games of all.
we're going to use this .add.rectangle, which just creates a rectangle. A road is kind of like a rectangle. Life is a highway. Config.width divided by 2. You might recognize that from how we added the Cody sprite. That just means center it on the screen. We want it to be in the center of the screen. And we're going to give it a Y value of 150. And so we're breaking this up into like kind of 50 pixel grid. Cody is 50 pixels by 50 pixels, and Cody is moving up and down by 50 pixels. So 150 is like 3 lanes down from the top, let's say. And so we're going to give it the whole, rectangle has 5 arguments that we're going to provide it. The x coordinate of the rectangle, the y coordinate of the center of the rectangle, the width, and the height, and then the color. So that's all 5. So the first thing that we have here is the x coordinate of the center of the rectangle, which is the center of the game. The next is the y coordinate of the center of the rectangle, which we're going to give 150. And that's another one of those values that you kind of play with and you think about and you have fun with as you design your own game. The next thing that we're going to add is the width of the road, and we want it to be as wide as the game itself, so config.width. And the next is the height, and we want each road to be 4 of these 50 pixel rows tall, I guess. So that's 4 times 50, which is 200. And I just give it this little gray by passing in this hex code 0xBBBBBB.
Oh, that's a lot of Bs.
That's a lot of Bs. It's 6 Bs altogether. That's a hex code. It's just a hexadecimal color code. You can learn more about those online. Oh no. Oh no.
Let's copy that and refresh. I don't think it's our code. I think it's just.
I see. We've run into
it's Command A and all that good jazz.
bit of an error.
Did you copy?
I did not copy.
Okay. Well. Visual code. Oh, okay. That's great. There was also a great question from Diego, asking what happens if we add in like arguments that aren't integers. In our chat, I actually encourage you guys to play around with that and see what actually happens. I only say that because I've done that numerous times as we've developed this course and found out for myself, and that's how I learned. But maybe we could also plug in a non-integer value here and see what happens.
Sure, absolutely. Let's.
Like if we do a string, I don't know.
A string? Oh, I thought you meant like a float.
Oh, yeah. I haven't even thought about floats for this one.
To be honest, I don't know the answer to that question of what happens if it's not an integer value. So I'm going to give it 200.25 here, and we're going to see. I don't know if we would actually be able to see if there's like a 0.25 increase to the height. That's not a very useful thing to do, I guess.
I don't think so.
I don't know that I would be able to tell.
Probably rounds.
It probably rounds, but is it floor? Is it truncation? I don't know.
Not entirely sure on that one either. I thought it was going off a string or like undefined before.
Right, if we give it like 200, I think that is not gonna, I don't think it's gonna like that.
Ooh, that's weird. Why does it go all the way up?
I have no idea. We're not gonna go into that probably too deep.
No.
I think it's a really good question, and I'll probably end up spending some time looking it up afterwards, so I'll let you know.
Yeah.
Thanks for fixing that.
No problem.
Cool. What's next? The next road. Let's add in 2 roads because we want Cody to have a storied adventure before Cody.
Oh, divide by 3. So, yeah, I'll answer that.
I'm just going to copy and paste this first line and create road 2. And we want road 2 to have the same x coordinate, but a different y coordinate. We're going to give it 450. And everything else the same, so we're going to have 2 roads here. We're going to have Cody start by crossing 1 road. Ooh, look at this.
Ah, I also got a question about that from John. John's coding along, thank you.
Yeah, and it looks like Cody is going right underneath the road, which is 100% not what we want, right?
Nope.
So how do you think we might fix this?
It seems like it's just how like phaser is reading our code, or even JavaScript is being read, because it's going from top down, right? So if we
Right.
load the player before we load the roads, the roads will have this thing called like a Z index that makes it pop like closer to the front of the screen than Cody would be. So I see that Tim's copied the code to create Cody, and we're pasting it underneath the road creation code.
Yeah, we're moving this this GameState.player creation. I think that Phaser automatically assigns Z indexes to the objects as you create them, and so since this one is the last one that gets created, I think you can update it manually, but it's maybe clearer to not have to do that if you just say, oh, I'm going to put everything on the page first and then have Cody like walk over the road. So if I save this and start running it like this, you'll see Cody on top of the street
Awesome.
as intended. Cool. What is next? We're going to start talking about enemies, right?
Yep.
That's what makes a game, isn't it?
I thought we were just crossing roads. I thought.
Yeah, my favorite step in any game development is making enemies, because making enemies is something that I'm really good at doing. So if you're out there and you want to be my enemy, actually, that doesn't sound that great.
Let's not encourage that.
Yeah.
Let's keep.
Let's
this
be
to the
friends
game.
instead. I make enough enemies as is here in the Phaser game. So what we're going to do is we're going to add a group. Groups. Yeah.
Group objects. So Tim's gonna write in the code for this, but our groups are basically like game objects that keep track of other game objects. You can think of them as a collection of other sprites, and we can use this group object to continuously make these kind of sprites. Okay. So Tim's written GameState.enemies, so that's going to be a property in our global variable. This.addGroup, which is going to allow us to then use enemies.addSprite to make enemies later.
Cool. Yeah. Let's start. Let's maybe get to cooking up our make bug function.
Make bug.
So the way that we're going to be making these enemies is with a timed event. Thanks, Laura, moderator.
Yep.
Um,
I think we're also going to be in create though.
we should. Well, okay. Let's add this in create then. So function. Ooh, I'm going to give it another space there. Function make bug. And what we're going to do is how to talk through this a little bit.
So in the classic Frogger game, it seems like bugs or cars appear on like road lanes, right?
Mm-hmm.
And we've thought of the road or our lanes in kind of 10 rows. Is that right?
Yeah, altogether 1, 2, 3, 4, 8 different rows.
8 different rows.
Yeah.
So we'll need to make enemies for every row. And I think that's like a nice first step that we should do, because then later on we can take these enemies and we can start moving it. But it's a matter of like taking these problems, breaking them down to smaller pieces, and then iterating them.
So actually, I think the first thing that I'm going to do is just get a bug on the screen.
That sounds great.
Yeah. So we're going to create, and we're going to give it a start x, an x value of, let me see. Let's start with 0, and then we're going to give it a y value. Let's just kind of
25.
bring it down a little bit. Let's actually see if we can just get one on the screen first. And then we're going to give it bug1, which is the name of one of these bugs that I'm going to point at the screen.
Yep.
That we've loaded an image asset for. And so let's start with that, and let's just make a bug and call make bug in order to see if that works. All right, cool. We have got a bug on the screen, and we're going to fill the screen with these bugs in due time, but we're going to talk first about how this bug is facing downwards, which is not the direction we want the bug to be facing in. We want to actually move it from left to right and from right to left. So what a sprite has is a property called angle. And what you can do is call a function on the sprite called setAngle, And if we set it to 90, that's going to turn the bug 90 degrees.
Clockwise.
Right. I don't know how I gestured, but the way that Kenny is saying it is the way that it gets turned in the direction of the clock. So
Right.
like that, yes. So that means that bugs set at a 90-degree angle are going to be the ones that are moving from right to left, and then bugs set at, you can pass either 270. Ooh, that's not what I meant to do. And it'll turn it the other way, or, I mean, you might prefer to do minus 90. It's the same thing.
Yeah.
So we're going to start with 90, and we're going to talk a little bit more about where we want to put these bugs as we create them. So we kind of touched a little bit on how there are different lanes.
Right.
And so we want to kind of interspace these lanes. So have one lane of bugs moving this way, one lane of bugs moving the other way, and continue to flip between the two of them. And a way to do that is, oh good, my enemies are chiming in.
Made them know mine too.
Glad to see they can all see me succeeding here.
Haters gonna hate.
So let me think. How do we want to move forward with the creation of these bugs?
Yeah, I think that's one of the big struggles of like game development or coding in general. That it just seems like there's so many different solutions that we could do. But while we were doing this, one thing that we thought of is like, since we do have defined a defined height, and Cody can only move in a defined up fashion, like 50 pixels each time up gets pressed, that we can make an array containing the numbers of like lane multipliers that we do want.
Mm-hmm. So we can make a set of different lanes. So 1, 2. So like, you'll notice that this is the
last
at
lane?
25 by 25. This is the last lane. So this would be 75, 25 right here, or 25, 75. Sorry, with a y with an x value of 25 will keep you on this side, and a y value of 75 will put you here. And if you keep adding 50, 125 onto the next lane. And so it's a multiplier of 50 that you add to 25. So the multiplier of 50, sorry, what am I going to say? This first lane is number 1.
Yeah, because we're going to multiply 1 by 50 to get to that second to last lane, or the second lane, however you want to think of it, from top to bottom. And then Tim has actually filled in the rest of the lanes that we need to multiply by 50 to get the values in which we want the lanes, the bugs to be on.
You'll notice that I skipped 5 and 6 here, and that corresponds to this safe patch here that doesn't correspond to a road, and this next safe patch. This is 5 and this is 6. And we're going to be using these. I think it's going to be a little more understandable why we're making this array as we come around to like getting the bugs to be made generically. What should I do next?
So let's see. I think each lane is going to correspond to something, and then we can go inside make bug and just create that function first before we make the event that continuously calls make bug.
Okay, yeah. Let's, should we pass in lane as an argument first, or should we?
That or just hard code.
Okay, yeah. So we're gonna give it a lane of 1 right now, and we're gonna see if we can build out this first lane. So what do we want the y value of every bug that turns onto this lane to be? So I'm gonna make a, every time this gets called with a lane, we wanna give it the y value that corresponds to that lane. And so we talked a little bit about how the lane is a multiplier. Config.height, good to see you, Diana. Happy birthday, Diana. It's always someone's birthday. Here at the Codecademy live stream.
Nice.
Config.height. What am I doing? Sorry, I got lost. We want to subtract from the bottom here. It's just I guess it's a little bit easier for me. I'm just going to write this in, and then I'm going to talk a little bit about what the process was for deciding on this. So maybe if you've been listening to what we've been saying, this makes a little bit of sense to you, but here's how it all works out. We take the height, which is the bottom of the game, and then we subtract enough to get the bug to appear on the right lane that we expect it to. And the amount that we subtract is 25, so that the bug is centered. So config.height minus 25 is going to put it on the right, on this bottom lane here. And then we continue to subtract 50 times every lane. So if you're in the first lane, actually what you're going to be is in this bottommost lane here. And if we continue to generate enemies at this start Y value, we're going to continue to generate enemies on this first road, on this first part of the first road. Cool. So what do we want to do? We also want to figure out what the start X value is. So we're going to try to figure out, we're going to let start X because it's going to depend.
Right, because depending on which direction it's going, right, we might want it to show up on the left side of the screen or the right side of the screen first.
So someone was talking about the modulo in chat earlier. We are going to be using the modulus operator in order to determine whether our lane is even or not. And that just means if the lane is 1 or 3 or 5, we're going to be moving it from right to left. And if the lane is 2 or 4 or 6, we're going to be moving it from left to right.
Sounds good.
And it's just an easy way to flip between values like that. So what we're going to do here is we're going to check if lane %2, and that's the modulus operator. It says divide by 2 and give me the remainder. And we're going to check if that's triple equals to 0. Is that how you say that?
Yep.
Cool. And if it is, we're going to give it a start X value of the width. We're going to start it all the way on the right side. And we're going to give it the angle.
Oh, okay.
I'm going to add angle here. So we're going to set the angle and the X value in the same place because that's where the two are going to be decided. If it's moving from right to left, you want to set the X value to be as far right as possible and set the angle so that it's facing the left. And if it's moving the other way, then you want to set the start X to be 0 and the angle so that it's facing to the right. And so for the angle, we want 90 here. And then in our else bracket, we want our else suite, we want the start X value to be 0 and we want the angle to be minus 90. So what we can do here is change this angle that we have hard-coded to angle. Mm-hmm. We can change this X value that we have hard-coded to start X, and we can change this to start Y. So let's see what happens when we make a bug now.
Well,
we've got a bug right on the bottom here, moving from left to right.
Well,
that's great. Or it's not moving.
It's not moving just yet.
It's not moving. That's correct.
But that's expected.
Here at Codecademy, we can say one thing for certain, and it's that this bug is not moving.
Not moving.
So do you think I should flesh out the make bug function, or maybe we should talk about the event first? Or we should start moving the bug, shouldn't we?
I think we could jump to moving the bug. I think that'd be more interesting, and we can fill in the details later.
Cool.
Okay. Yeah, so while we're doing that, it's just like we mentioned before, there's a lot of different ways to maybe handle this. And this is one way that we found it to be easier. Charlie, great question. Instead of -90, can it be 270? And we kind of touched upon that before. It's definitely possible. You can use that as well.
Yep.
We have the chat asking to move the bug, so I think
move the bug.
We have to abide. We have to move
yeah,
the
we
bug.
must move the bug.
Must move
Thank
it.
you, Maurizio. I'll see you in Miami. Wow. Okay, so let's move the bug in our update function.
Right.
That's where we are. Wow. Where are we? We're in our update function here, and we're past all of these cursor movement operations that we've defined, and we're going to add in a for loop. So game state.enemies.getChildren and this gets all of the enemies that have been added to the enemies group.
Right.
And we're going to give it a for each. And that's a little JavaScript fun for you.
A little iterator, yeah.
And here's a little some function syntax. It's kind of funny. We don't really often use this arrow syntax in our phaser lessons.
We try to keep it as accessible as possible, and some people might not be familiar with it, but researching and knowing some of these latest methods might really be helpful for learning the program in phaser or JavaScript moving forward anyways.
220.
Yeah, we have.
We are just having entirely too much fun here. We're going to start building out some more game real quick.
Yeah.
Bug.angle.
Why use arrows when you have phasers? Oh, Patrick.
I would say, I mean, it's up to you guys, but I would say go slow and show like moving the bug, or
Okay.
I wouldn't speed through the game.
I don't want to speed through the game, but I do want to get the bugs moving and collision happening.
Yeah,
Yeah.
I think that's the
Cool.
baseline
Yeah.
for us.
Sorry for taking a little bit more time than maybe.
But we do appreciate you guys sticking around and listening and asking questions in the chat. This really makes it fun.
Oh, should we talk about giving the bug a speed, or should we just give them all the same? Here
Yeah.
in our bug constructor, we can also just give the bug a speed.
Yeah.
And this is not a phaser built in at all. This is just a number that we can assign to the bug itself so that we can use it. And let's give it a speed of, we'll move Cody at 5.
25. Let's
So
let him
let's-
outrun. Oh, 9? 9.
Oh, we want Cody to outrun the bugs?
I think in the earlier stages, it should be like slightly easier.
All right, we'll start with 4. If you want to amp up the difficulty on your own Frogger game, you'll know that you can change this speed to be much higher.
Right. Definitely something that you want to play around with. Again, personal preference or how fun you want to make it seem.
In the steps, we cover giving each of these lanes a different speed. I'm not sure that we'll be able to cover that today.
Well, let's see.
So we're going to go into, so here you check, or here we check if the bug angle is 90. We're going to check if the bug angle is -90, and we're going to use that to determine which direction the bug is facing, because that is literally which direction the bug is facing.
If we want to increase or decrease that x value, right?
So if the bug is facing to the left, what do we want to do to the x value? Do we want to subtract or do we want to add to it? If
So that was a question for you guys in chat.
I know
Add
that
or
we already
subtract?
kind of asked this question and you were all very good at it, so.
But we did that for the y value. And
Yeah.
This time we're doing it for the x. So
And they're different.
we're covering both, covering all bases.
Subtract. Yeah, way to go. Div Nation, Brian Cox, you got it.
We have one who said add to the x value though.
Oh,
So-
no.
I don't know. Definitely something that it's Sean. It's okay. I probably would have said add as well. It's a 50-50 shot. And for me, honestly, it's something that I play around with. And it's like, if this doesn't work, let me try it again.
We want to add for this bug in particular, but if the bug is facing to the left, which it is when we've turned it 90 degrees,
Yeah.
yeah, we want to subtract. So bug.x
So
minus
this is-
equals, and we're giving it bug.speed. And then this one plus equals bug.speed. And let's move the bug, shall we? Does this move the bug? Are we going to move the bug?
I hope it does.
Wow. All right. That is the first bug moving across the screen. Fantastic. We're almost done, really.
Or at least with the basics.
We're almost done with the very basics of this game. Not nearly near as far into the game as we kind of expected beforehand.
We were kind of ambitious on this. But I think that's a great first step, right? We have the bug moving. And do you want, in this next step, do you want to
I'm going to add the event.
events? So
I
let's,
really desperately want to add the event.
let's do that.
Yeah. So in order to continue creating bugs in our code, something else that I'm excellent at doing, we want to add in a timed event.
Aren't we all?
Yeah. Here at Codecademy, we are nothing if not professionals at adding bugs to code. Hopefully you are too, because that means that you're a programmer. That's how you figure it out. If you added a bug to your own code, you're coding. Congratulations.
Yep.
So what we want to do is do this dot events, right?
This .time .add event, I
This
believe,
dot time, yeah.
is gonna allow us to create a like in-game loop that calls a function depending on depending on the properties that we include in it. So in this case, we're gonna use loop being true. But if you wanted the event to only happen, let's say 50 times, you could use another property called repeat and use 50 as the property instead. But this case specifically, let's see what Tim uses.
Yeah, I'm going to give it a little slightly random delay. So every time that this event gets called, it could be, and I'm going to give it a start time too. Do I want that?
180? I mean, could. Doesn't have to, right? Like that's saying like at the minimum, just in case there is no delay at all.
Right. Add a little bit of delay.
Yeah.
Yeah, we
need
want
a
it. We
constant.
want to make sure that it's that there is some amount of delay between each of the bugs that we add, so that we'll be able to get Cody successfully
Right.
through.
So the reason that Tim added the constant right there, 1,800, is because the delay is determining how long it is between when the first function is called and the next function is being called. So if we want make bug, we don't want it to have, let's say, math.random returns 0, and it just constantly creates a bug, and we can't even get that through that stream of bugs. So we want to have it wait at least 1,800 milliseconds or 1.8 seconds. And we've played around with these values a little bit beforehand so that we're not just crazy guessing here.
Cool. Oh. Excellent. Good to see you, Mel.
Depends if you like Cody. Charlie, come on. I thought you were on our team.
Yeah, really, Charlie. I do want some coffee. So I've added this callback scope to the event, and that means that we can access, and we'll see as we build this like loop a little bit more. Instead of hard coding the lane here, we can give a lane that's been provided to the code. So what this is hopefully going to do is continue to make bugs that move to the right. Well, I made a bug.
No, I think it's just the delay.
Oh, the delay is a little bit long.
Yeah.
But that's good because we want to. Oh no. Well, we'll figure out how to. We maybe can get to collision.
I think
code?
so. I think
Okay.
after this, it's a matter of like allowing.
All right. Well, what I'm gonna also do here, and we're gonna move a little bit through, is for, I guess lane of lanes is what I'm gonna do for let lane of lanes.
Okay.
And I'm gonna loop over this event so that we can create. Can I successfully do this? Yes, I can do it. Okay. If you hit, well, on a Mac it's Command and the right bracket, you can indent the code, and I always somehow miss that.
I also learned from a coach lit before that we can also tab it.
Oh yeah?
Yeah.
You can just tab.
You
That's
can tab
fun.
and highlight and tab.
So here we're looping over this, and we're going to create a timed event for each of these lanes that we've defined up here. And what that's going to do is create bugs in each of the different.
I feel like that lane callback scope might be. Oh. Okay.
All
No,
right.
It works.
We got oh, now we're talking. That's correct. We have a lot
Ooh.
of bugs going on here. In fact, I'm going to change the color of this bug. In the steps you can go over, we kind of automate making each lane a different kind of bug. But the orange one is giving me the
willies.
willies, so let's go with the green one, which is a little bit nicer looking, I think. Oh, Jennifer Teacher. You're very welcome. Thank you for tuning in.
Seriously.
Really appreciate it.
Kind words.
So, what are we doing next? We're going to add the collision, aren't we?
Yeah, we got those bugs moving, but Cody's just barreling right through them.
Yeah, you have to be able to lose a game, you know, in order to make winning really, truly mean anything. So let's talk about how we're going to get Cody to lose.
Yeah. So I guess in taking a step back and talking about like collision detection as a whole in game development, It's a matter of like when two objects like collide, for lack of a better word, come into contact with each other, right? So to do that, we need to know where they are in the game, like what's their bounds, what's like their outline, I guess, and where's the enemy sprite outline. And when those two overlap a little bit or touch each other, that's when it's like, no, we can't have that happen. It's game over for you.
Right. And so we loop over each of the bugs here in our update. We wrote this a little bit earlier to move the bugs around. What we can also do here in this for each is check if the bug and Cody overlap. And we're going to do that with a little geometry. And so what we're going to do is we're going to check if phaser.geom.intersects rectangle to rectangle. So that's going to check whether or not the rectangle of Cody, then that's the whole sprite. That's
Well, we have to take one step back, and we have to grab Cody as the rectangle first, too. Like,
right. We have to use the player rectangle.
Yeah.
I see. Oh, excuse me. Yeah. So we want to actually grab the player rectangle first.
very kind words. Thanks,
I'm afraid
Vanessa.
I'll have to use math. We will.
That's right, Matthew.
Cool. So we're going to get the rectangle that corresponds to Cody here with player rect, and we're going to assign that to a part of our game state so that we can access it later. We're going to grab that from our game state.player that corresponds to Cody there. Get bounds.
Right.
That's the method that we're going to use in order to get the bounds of the player.
Yeah.
It's a little. I like it when you can describe what something is doing by reading the sequence here. We want to look at our game state and get the player and get the bounds from that.
Makes sense.
And that's quite nice.
And that's one of the things that like phaser gives you right out the box, which if we had to do, we would maybe have to find the x coordinate, the y coordinate, or the top left, top right, bottom left, bottom right coordinates, and figure out all those math. But phaser just gives us get bounds, and we get a rectangle from that, which is awesome.
It's called an AABB, an absolutely around bounding box. It is a fun little piece of code to have to write yourself. It's so easy to get wrong, and I'm speaking from experience.
I don't think I've tried, but I'll take your word for it.
Yeah, I don't recommend it unless you want to, in which case, go for it. It's always fun to figure out new things. So we're going to use this player rectangle and check if it intersects with each of these different bugs here. And we're going to do that with bug.getBounds. The reason why we call player.getBounds outside of the for loop is so that we don't keep on calling it for each one of our bugs. Yeah. We don't need that. We know where the player is. The player's in the same place, but each of the bugs is in a different place. So that's why we have to call that, or we call that before, but we call the bug.getBounds here.
Exactly.
Cool. And if this whole thing is true, this somewhat monstrous but hopefully self-explanatory series of statements is true, we're going to add some text that says game over. That's the first thing that we're going to do. And then we're going to probably, I would say, pause the physics is probably what we should do. I'm not keeping track of the events or anything, so I can't destroy those.
Right.
But if we pause the physics, we'll get the bugs to stop moving.
But the thing is here, we never included physics.
Oh yeah, we never included physics.
So Tim is actually mentioning another method that we can use had we included physics in our game.
Right.
But we didn't. And so the way that we can manage this, though, is like signing when like a game state is active, like when it's being played. And then in our update, we can check if game state is active or playable. And if it's not playable, then we don't do any of this stuff.
Cool. I'm going to first here, I'm going to add in the game over text. And then I guess, do you want to talk a little bit more about how the game state is active might interact with? I want to talk a little bit about how the step-by-step code will look like to someone who's following along with the project, not as we've done it here today, but as how we've kind of laid it out.
Sure, yeah. So game state not active. So that's going to be another property that we append to our game state global variable. And that, at the beginning, we're going to set to true. If active is true, then we want the game to be playable. And to do that, we can add it in our create function just to assign it true first, and to check if it's still true throughout. In our update function, we can wrap like our controls around that fact of checking if game state active is true. And if it is, we should be able to control the player, we should have collision detection, we should have all that good jazz. But if it's ever false, then in our update, we'll see that it's false, and we won't be able to control Cody anymore, and our bugs will stop moving. And eventually, we might even want to like stop the event that is creating our bugs, right?
Cool. I'm just going to cover a little bit about all the stuff that I wrote, which is pretty much exactly what you just described. So I added this text that says game over when you intersect, and then I added this if statement around all of our update function that just checks if GameState.active is true. And the last thing that I'm going to do here is inside this intersection, I'm going to set GameState active. It's not is active, it's active. That's what I wrote. GameState.active to false. So this means after we hit one of our bugs, where the bugs are going to stop moving, Cody's not going to stop moving, and we're going to see the words game over. So hopefully, well, going to just refresh real fast.
Just click there. No. Click and then yeah.
Yeah,
Sweet.
there we go. Oh no. Well,
I think you just have to save again or paste over.
talk about adding bugs to code.
Open the console and edit its bug.
What?
You can open the console and edit its bug.
Oh yeah, yeah. So here's something that you can totally do is inspect the element here, and it's a little busy because there's a lot of stuff going on, but rectangle to rectangle is what it doesn't understand.
Ooh,
So
okay.
let's come down to this part here. And I think it's because I spelled intersects wrong.
Yeah, that's what it's finding undefined. So
Insects was what was on the brain there. But if we update that, it just says game over. Oh.
I've had this issue before. Where let's see, player rect, and then bug get bounds.
Curious. Very interesting. So, since we can use the console, we can just start debugging by console logging stuff.
Yep. You didn't set the game state.
Game state for which?
I don't know. That's what it's false by default.
Oh, did I? Did I set it false? No, I set it active in create, and so it drops into this if statement.
Right.
And then it gets here, and what does it do? So I'm gonna check the console, and oh, okay. Our bug does not have like bounds, and for some reason that trues this. Very interesting. See if I understand what's going on here. Should I be put another time key?
Is bug a thing?
Bug?
Bug
Yeah,
should
do
be
you-
a thing
do you
in our
miss dot or anything?
Yeah.
the parameter in our callback function.
Very curious.
You're right. Is it intersects with a is intersects spelled correctly?
I believe it is, because this is
Yeah.
returning true somehow. But bug.getBounds is giving us this not a number laden object. And all of that together is making this So this is the fun part of coding. Welcome. And I don't know if I'm going to be able to fix this.
Can we
It's
save
not
the
in
can we
time.
save the bounds in a variable? And can we just try bug rect equals bug.getBounds and then print that out? Like right where you make player rect read there as well.
It's got to be in this callback because it's for each of the different
Right,
bugs,
right.
though. But curious. If you catch what's going on, please fill us in. It's a fun way to be finishing off our live stream here.
Isn't it? So let's see. Are we inside that scope as well?
Can I like auto format this?
No,
No way. Okay.
not with what we have. So we're in there. So constant. Bugs haven't loaded when you're getting the balance.
Yeah, I think it's possible that we have like a bug that doesn't really.
That just hasn't been there yet.
I don't know, because when we create them, we give them x and y values. They don't get added before they are assigned those things. You are certainly not the one who struggles to figure out your coding mistakes, Vanessa.
Definitely not.
You are in, I would love to call myself good company.
Lanes. So we're making that event. Calling.
Yeah, you was saying on line 74 there's a missing semicolon, but that shouldn't.
I'll add the semicolon though. I want you to feel I'm very bad at adding semicolons.
Player rect intersects. It's returning true. Or at least it's returning truthy.
Yes, it is returning something positive here. I don't know. I'm not sure.
I'm a bit stumped by this as well. If we're doing that conditional and calling rect, it's getting the balance.
You logged player rect, right?
Yeah, player rect
And that looked good.
is
Player X looks good. The bug rectangle is what's coming back all
Yeah.
messed up. So maybe I'm saying get bounds wrong, but no.
get bounds looks to be the same in both situations.
Yeah. Very, very curious.
Yeah, good call.
Yeah.
Yeah.
You just start console logging stuff. For and nan. So this bug does not have a y value. Why doesn't this bug have a y value? Do I never define start.y? I do. Start y. Am I passing this correctly? Yes, I am.
Lane. One Cody, multiple bugs. That could be done, but we're making this collider happen for every single bug, so that it checks when that bug collides with Cody.
It's funny, it's the first bug too. You can tell because every time you refresh the page, it only prints out one of these values. So the first time that it tries to do one of these rectangle to rectangle comparisons, it is blowing up. Which is a real shame, because I wanted to play Frogger.
Yeah.
Copy all, yeah. Yep.
Let's just try to remove that for now, like the if.
How is it has to know its y position because the lanes are working correctly.
Yeah, the lanes are working correctly. There is a Y position for it, so it's very strange. It's very, very curious. If you're catching on to something here, please let us know.
And we didn't set bug rect. I think we do right there where it's line 73. It's const bug rect.
Oh, should it? No, but it's.
It would be fine with const. We can try let.
I can get rid of it and put it back in the.
Before where it's bug
Yeah.
get bounds.
Because I'm actually this isn't used anymore, or this is used. Okay. Well.
So referring to the whole screen as the collision. Whole screen, eh?
This is funny.
Let's take a look above. Let's see, game state road 1. Is road 1 a rectangle, by chance?
Is which?
When we were at road 1,
Mhm.
a rectangle. So
Road 1 is a rectangle. Yeah, we can check if road 1. Very good idea.
let's see what happens here. Oh, but we don't add any text.
But we do add a bug that does not have. Yeah, there's one with a nan y value. It's interesting. But what we should do is probably I'm gonna switch this back. I have an idea.
Okay. I think it's probably where we're creating our bugs.
It must be, yeah. What I'm going to do here, just to get on with it, sort of, if start x and start y. I'm just going to make sure that these two values exist
Before we create them.
before we create the bug, and that should hopefully fix our issue. There we go.
Oh.
Okay. So our start y was getting messed up when in the odd case. But if we do this now, you can see.
Awesome.
Cool. It had to do with this offending piece of line of code, I suppose,
Not a number.
which looks just fine to me.
Yeah, I think we should, if anything, let's console log what start y is then.
Yeah. Here, I'm gonna dot log. Wow, I'm gonna
Terminal error.
use this correctly. I'm gonna give, and I'm just gonna. So I'm passing a couple of things to console log, and I'm going to stop console logging the other thing. This. And this. So that all we see is this one, which will give us the start y and then the different components that we have inside this calculation here.
Sweet. Good
and then
idea.
we run this.
Oh, because you have a comma there.
Yes. I do love to use commas.
I guess it is really fitting that our game is all about bugs and making bugs.
It truly is. So yeah, here we are, nan 600. I think I know what happens.
Oh. Enlighten us, Tim.
Config.height is defined later on down in the file. And so we use it kind of here just possibly before the phaser code realizes that it's been defined.
Yeah.
And that's a bug.
I see. How about in this case, then let's just turn config.height into 700?
Yep.
No?
Yeah, let's do that. Right here, we're going to change this to 700. That's the value. That doesn't work. I think actually it was 600.
Oh, 600 for the height? That would mess things up.
But we're still getting a small issue here with the odd y values not working out right. Very curious. I don't know what to say.
And it's always the start Y value that's returning.
Yeah, I'm actually kind of confused because I don't think that it's not just the config.height then, if we're still getting this issue.
Nope.
Did I define lanes correctly? Looks right to me. Oh, yeah, this dot lane. And we iterate over a lane. Is it of? Lane of lanes. Change the 270 to a minus 90. That's actually probably a good idea. Oh no, it is a minus 90.
Can we try, because I
Yeah.
think in here, our lane callback. Can we see what lane, what was being console logged for lane?
Sure.
For there?
Yeah, we'll just log lane first.
Oh, okay.
Yeah, we're getting stuff for both odd and even lanes, so it's very interesting that only the bugs moving from the right to the left are appearing. Maybe it had to do with this. No, that looks right.
That looks fine to me.
Maybe that's what you meant by this. Nope.
It always starts off like that, just undefined.
Very weird. That's strange, but I think that we should probably be wrapping up the live stream.
Yeah.
Thank you all for spending all of this time with us.
Yeah, really.
I really appreciate you taking the time out of your day to try and develop a little bit of Frogger. Turns out the real bugs was the friends we made along the way.
Classic.
Yeah.
Yep. And thanks for being so attentive and really asking questions and helping us debug this. If you do want to see our final version of what Frogger would look like, in our steps finishing touches, we actually do have the code to make a more functional Frogger game. And I would love to see that more in action. If you had been coding along and don't want to overwrite your code, the next steps would be like thinking about what the win condition would be. Thinking about how to set or remove the event that's creating the bugs. Maybe thinking about how to add a life system, like multiple lives. Many things that you can do with this game and that we haven't even touched upon. All right. I'll spend the last 2 minutes. Oh, you won! High five. Left me out on that other one, but okay.
Yeah, I
Yeah.
left you hanging once.
Hanging on the one.
I love that feedback form I just posted.
Right. Thanks, Alex.
Please visit the feedback forum and let us know if you enjoyed this or if you didn't enjoy this, what we could be doing better, what we could be doing much worse. I hope that you enjoyed learning a little bit of Phaser. Sorry about the technical issues.
Yeah.
Programming, especially in a live setting, is fraught a little bit. You know, things happen, stuff gets typoed that you miss somehow. Isn't that a lot like life?
Yeah, we're gonna take a look back on this and see what we could have done to fix it. But I think yeah, the code is there if you want to play around with it. And again, just much appreciate you guys chiming in, joining us for this lengthy live stream.
Cool. Yeah. I'm gonna shut the stream off. Bye.
Bye.